All right, Math 707, Data Analysis, Study Guide, problem number 1. The mean of a set is affected by outliers. First, let's talk about what is an outlier. Okay, in your unit, assignment 3, using mean, median, and mode, in the Let's Review section, section 4, they said outliers are values in a data set that are far removed from the rest of the data. So, if you were to look at this list of numbers right here, which number would you say was the outlier? 25, of course, because it is the most removed from the rest of the data. Also in that lesson, it said the mean is most affected by outliers. Also in quiz 1, describing data, we have a question on here and it says an outlier always affects the mean, and the answer is true. So the mean of a set is affected by outliers. This is true. Okay, problem number 2. In the following set, the median is the most effective measure of central tendency if you want to emphasize how large the values are. Okay, central tendency is measured by the mean, the median, and the mode, but not the range. So we need to be able to find the mean, the median, and the mode to be able to answer this question, whether it's true or false. You know how to find the mean. You add all the numbers, and then you divide by how many numbers you added. Since there are 5 numbers, we will divide by 5. Okay, so I added the numbers of the mean, and I got 154. Now I'm going to divide that by... Oops, made a mistake. We are missing a 21 in this list of numbers, so let's redo that. Okay, now we have the right answer because we have 2 21s, and our answer is 175. And now I'm going to divide this by 5, since there are 1, 2, 3, 4, 5 numbers. And 175 divided by 5 is 35. So our mean is 35. Okay, to find the median, I put the numbers in order from smallest to largest. And the median is the middle number, so we're going to circle the middle number. That's our median, 32. Mode is easy enough. It's the number that appears the most. Remember that? So the number that appears the most is obviously 21. So looking at these 3 measures of central tendency, 35, 32, and 21, the largest value is 35. We would want to use the mean to emphasize the largest value. So this is false because they put median and it should say mean. Okay, problem number 3. The following pictograph shows the attendance at each seminar at a financial conference. The number of people that attended the Saving for Retirement seminar was 125. So we have to look down here at the key. 1 stick figure equals 50 people. So the Making a Budget seminar had 150. Half of 50 is 75. Is 25. So that would be 175. Saving for Retirement is 125. Being Frugal is 100, 250. And Good Spending Habits is 100, 200. So this is true. The Saving for Retirement seminar is 125. Okay, problem number 4. At a financial conference, the 750, remember this number, it's important. That means the total attendees were 750. They were given the choice of turkey, ham, both, or neither in their sack lunch. 100 of the attendees chose neither, and 300 chose both. If a total of 400 people had turkey on their sandwich, let's pause right here. If this total needs to be 400, then this needs to equal 100. Do you see that? Because 300 plus 100 is 400. Okay, so if this is 100 plus 300 is 400, plus 100 more is 500, and then 100 more is 600. The total of this Venn diagram is 600. Now that doesn't match the information given. The information given said that 750 attendees in this Venn diagram. So this information, where did we pause? The following Venn diagram could be used to find the number of people that only had ham. This Venn diagram isn't matching up with the information given. So this is an invalid Venn diagram. It doesn't work for this information. We're going to have to put false. It's not going to help us find ham because the numbers aren't matching up. So even though it says only had ham was 100 people, we can't use that information because 600 doesn't match 750. So we're going to have to put false on this. Okay, for problem number 5, let's go over some graphs to show correlation on scatter plots. These are called scatter plots. They take these dots and they scatter them on the plot. If you see that the dots are trending upwards, you draw a line like through the middle of the dots. This is called positive correlation. If you see the dots trending down, draw a line through the middle of the dots. This is called negative correlation. And then when the dots are scattered kind of just all over the graph, there's nowhere to draw a line. I mean, your line would be like, I don't know, maybe like that. You would say that is no correlation. Okay, so remember this is positive, negative, and no. So problem number 5, we could see that these are trending up, making it positive. And so this is true. Okay, looking at number 6, Ben is taking a typing class and the following line graph represents the number of words per minute he was able to type each week. According to the graph, Ben was able to type 10 less words in the first week than in the third week. So we have to identify how many words did he type in the first week. 15 words per minute. And how many did he type in the third week? 25 words per minute. If you subtract 25 and 15, you do get 10. Oop, 15, not 10. Getting ahead of myself. So this is true. Problem number 7, which of the following questions represents a biased question? As you can see, there's a fill in the blank down here. What is the difference between random and biased? I just looked this up on the internet. It says participants in random samples are simply chosen at random. On the other hand, biased samples always have problems. They portray an image that is out of line with the real truth, which means that they are useless to most people. And this is something that you can write in for your answer here if you want. So this part that says they portray an image that is out of line with the real truth can be seen in this question here. Would you rather eat delicious ice cream or disgusting Brussels sprouts? See, that's kind of out of line with the real truth. I mean, some ice cream is disgusting. Some Brussels sprouts are delicious. This isn't really true. This is opinion. So this is what we would choose as a biased question. Every other question is just the straight facts. Do you plan to vote yes or no on measure 2? They weren't trying to persuade you to do either or. do you prefer to wear tennis shoes or sandals? That's just very bland, very basic. That's usually what you would use for a random sample. These are all pretty random questions. As you go down the line, they're not trying to persuade you to choose either or. They're just saying, what's your favorite color? And when you finally get to the last one, they try to persuade you with these adjectives here. So that makes this a biased question. Okay, problem number 8. 4 out of 15 people surveyed say they plan to vote yes on measure 2. Based on this sample, how many people out of 10 would you, 210 would you expect to vote yes? So what we did here is we created a proportion. Remember, we're going to cross multiply. So 4 times 210 is 840, and then 15 times x is 15x. To solve this, we do the opposite of what's happening here. What's happening here is multiplication, 15 times x. So we're going to divide both sides by 15. Canceling these out, all you have left is x equals 840 divided by 15 is 56. So sometimes when you see these three numbers and they're looking for that fourth missing number, one easy thing to remember is try setting it up in a proportion. A lot of times that'll help you find that missing number. Okay, problem number 9. Taylor earned the following scores on her first 10 quizzes. What is the median of her scores? Okay, what do we do if we're looking for the median? Okay, if you said put the numbers in order from smallest to largest, you were right. I like to cross them out as I go, and then I also like to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and make sure my list matches 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, making sure I didn't leave out any numbers. Okay, once we put them in order from smallest to largest, we need to find the middle number. This is an even amount, so we will have 2 middle numbers. I believe it's going to be 1, 2, 3, 4, 5. Yeah, right here. Okay, so 86 plus 87 is 173. When you divide that by 2, you get 86.5. And that's your median. Okay, problem number 10. Taylor earned these scores on her first 10 quizzes. What would she need to earn on the 11th test in order to have a mean score of 87? Okay, how do we find the mean? Do you remember? Okay, if you said add them all up and divide by 11, you were correct. So let's add all this up. As you can see, there's a variable over here. We can't add that, but we can add all the rest of these numbers. Okay, and once we add all 10 of these numbers, we get 858 plus x. You can't add x, it's not a like term. To keep solving this, I would like change it to a proportion and do that cross multiply thing we do with proportions. So let's see, what's 11 times 8. So this becomes 957 equals 858 plus x. Okay, now we're just down to one step that we need to solve this problem, and since it's adding, we're going to subtract 858 from both sides. And 858 minus 858 is 0, so all that's left is x. X equals 99. Now it looks like we have a problem on the study guide because there's no 99. So let's check our work and make sure we have the right answer. So if we added all these and changed this to a 99 and then divided it by 11, would it give us a mean score of 87? Let's check our work, okay? Since we've already added all these other numbers and we got 858, all we really need to add is 858 plus 99. That gives us 957 divided by 11. And 957 divided by 11 is 87, which is what we're wanting to get. So even though this answer isn't available here, we're going to write it in. And if that ever happens to you and you check your work and everything checks out, you can write in your own answer, and when you get to the score key, it'll show you if it's true or not. Problem number 11, what is the lowest value in the set of data represented on the box and whisker plot? I put abbreviations above each dot so you could remember this is your lowest value. This is the highest value, so the whiskers are lowest and highest values. The left end of the box, the lower quartile, the upper quartile, and the median. So the lowest value is 12. What is the interquartile range of the set of data represented by the following box and whisker plot? Do you remember how to find the range? If you said subtract, you were correct. To find the range, you subtract the highest value and the lowest value. This is asking for the quartile range, which are these two numbers right here, the lower quartile and the upper quartile. So we would have to subtract 18 and 14. That makes the interquartile range 4. Okay, problem number 13. A set of data has been organized using the stem and leaf plot below. What is the mode? Okay, do you remember how to find the mode? This is how I remember. The mode is the number that appears the most, okay? So we're seeing some numbers here that appear the most. 9. Now, it's not 9, it's 109. Do you understand that on the stem and leaf plot? This isn't 1, this is 81, 84, 90, 92, 97. So the numbers appearing the most are these 9s, and that makes them 109. That would be the mode. Okay, problem number 14. A histogram is being made for the following list of data. If the length of each interval is going to be 5, how many bars will there be on the histogram? All right, we need to take a minute and put these in order from smallest to largest. So take a minute to do that. All right, here they are, smallest to largest. Okay, now do you remember what a histogram looks like? Okay, here's a histogram. Has a bar going up and a bar going across. So when this says the length of each interval is going to be 5, these are intervals, what the bars are going to be measured by. So we got to figure out how many bars we're going to have. So what I did is I started with the smallest number, and I made the length of it 5. So 72, 73, 74, 75, 76. That's 5. And then I started from 77 and counted up 5. Then I counted 5 for this interval and this interval and this interval. And finally, this last interval. I couldn't stop here because I have a 98, and this interval would not include 98. So I had to go one more interval to be able to include 98. And once all your intervals include the smallest to the largest number, that's when you know you have enough intervals. So how many intervals are here? 1, 2, 3, 4, 5, 6. 6 intervals for this set of data on a histogram. Okay, for problem 15, this problem kind of works with the previous problem, so I'm leaving them together on the page. I just wrote in 3 and 4. That's what's on the second page. This one's asking if the length of each interval is 5, which we already read that up here. What will be the frequency of the second interval? Okay, let's look at the second interval. Here's the first interval. Here's the second interval. How many of these numbers fit into this interval? Okay, circled. The only two numbers that are going to fit in this interval are 78 and 81. So the frequency of the second interval is 2. Okay, problem number 16. Which of the following graphs are used to represent numerical data? All right, here is a picture of what the box and whisker looks like. It has all these numbers. The histogram usually has numbers in the frequency side, even sometimes down here in the, mostly down here in the on the x-axis. The line graph usually deals with numbers. The only one that's not used mainly or hardly ever for numerical data is the circle graph. So on this one, we can fill in all three of these for numerical data. Circle is the only one that we do not use for numerical data. Circle graph is something that's used for categorical data. So this is how you spell that. And it means categories. And these numerical, that means numbers. Okay, on this bar graph, they're wanting us to figure out how many candy bars were sold between the two classes, 7th and 8th graders, between Monday and Tuesday. So we got to figure out where these line up. I like to get a piece of paper and just scoot it up to the bar, the end of the bar, and see where it lines up. This one pretty much lines up with 100, so that's 100. This one lines up with, I'd say 80. This one lines up with 85. And then this one, 90. Okay? Add those four numbers up. 355. Okay, problem 18, they're asking us what is the central angle measure of the section representing miscellaneous. Whenever you're looking for central angle, you want to remember this number here, because this is how many degrees are in a circle. So if you can multiply this percentage by this degree, total degrees of 360, you'll get your how many degrees are in this angle right here. Always remember, change your percents to decimals before multiplying. So miscellaneous, and you could kind of see that this is a right angle if you've done geometry at all, and that a right angle is always 90 degrees. So for central angles, remember, multiply the percent by 360. Okay, this problem is pretty much like problem 18, except for instead of multiplying our percentages by 360, they give us a number to multiply by. The total budget is $3,500. So whichever category we're looking for, which here is bills, 40%, that's what we're going to have to multiply our budget, total budget by. Okay, 3,500 times 0.40 is 1,400. So they spend 1,400 on bills every month. Okay, last problem, number 20. The following scatter plot represents the scores of 12 students. You can see them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On a geography test compared to the number of hours that they studied for the test. Use the line of best fit. Here's that line of best fit. We talked about this earlier when we were talking about scatter plots. Draw the line between through the center of all the plots. Use that line to predict the score of a student who studied 2 hours. Come down here and find that 2 hours. Follow the graph up until you hit that line of best fit. And where did you hit it at? 16. So that would be your prediction of a student who studied 2 hours for the test. Okay, that's the end. Here's some things you really need to remember for the test. How do you find the mean? Remember, you add all the numbers and divide by how many are there. The median is always the middle number, but put them in order from smallest to largest. Mode is the number that appears the most. Not the biggest number, but the number that appears the most. Like if there's 2, 2, 2, 3, 4, 5, 6, 2 would be your mode. And then range, remember you need to subtract your largest and smallest numbers. That's it. Go get a 100.